Transitioning from an end cable tap box to an open bus in a utility vault requires careful planning and execution. Firstly, you will need to gather the necessary materials. These include an end cable tap box, flexible feeder cable suitable for the voltage and current rating, cable trays and supports, conduit which is optional for added protection, cable lugs and connectors, and a bus tap connector. The procedure involves several key steps. 1. Install the end cable tap box. Mount the end cable tap box at the beginning of the sandwiched feeder busway. Ensure proper grounding and accessibility. 2. Run the flexible feeder cable. Install the flexible feeder cable from the end cable tap box to the open bus in the utility vault. Consider using cable trays or supports to secure the cable overhead and prevent damage. 3. Terminate the flexible feeder cable. Connect the flexible feeder cable to the bus tap connector at the open bus in the vault. Use appropriate cable lugs and connectors to ensure secure and reliable contact. 4. Connect to the end cable tap box. On the other end, connect the flexible feeder cable to the end cable tap box using cable lugs and connectors. Tighten all connections to the specified torque. There are also optional steps that can enhance the installation. 1. Install conduit. For added protection, you can run the flexible feeder cable through conduit from the end cable tap box to the vault. This provides additional mechanical protection and reduces the risk of damage. Grounding is crucial for safety. Ensure that all components, including the end cable tap box and cable trays, are properly grounded to prevent electrical hazards. Choose flexible feeder cable with appropriate voltage and current ratings for the specific application. Follow all applicable electrical codes and manufacturer's instructions carefully when installing the transition. Ensure that all connections are secure and made by qualified electricians. Always prioritize safety when working with electrical systems. The end cable tap box serves as an interface point, allowing a transition from a cable-based system to a busway system. The selection of the end cable tap box should be based on the current carrying capacity, voltage rating, and compatibility with the existing busway. The flexible feeder cable plays a vital role in accommodating movement and vibration, which are common in utility vaults. The cable should be selected based on its flexibility, insulation type, and ability to withstand the environmental conditions in the vault. Cable trays and supports are essential for organizing and securing the flexible feeder cable. These supports prevent the cable from sagging or being damaged, ensuring long-term reliability. The choice of cable trays and supports should consider the weight of the cable and the available space in the utility vault. Conduit, while optional, provides an additional layer of protection for the flexible feeder cable. It shields the cable from physical damage, moisture, and other environmental factors. The use of conduit is particularly recommended in areas where the cable is exposed to potential hazards. Cable lugs and connectors are used to terminate the flexible feeder cable at both the end cable tap box and the bus tap connector. These connectors must be properly sized and installed to ensure a secure and reliable electrical connection. The selection of cable lugs and connectors should be based on the cable size, conductor material, and the specific requirements of the application. The bus tap connector is used to connect the flexible feeder cable to the open bus in the utility vault. This connector must be compatible with the busbar material and have the appropriate current carrying capacity. The installation of the bus tap connector should be done carefully to avoid damaging the busbar. Proper grounding is essential for preventing electrical hazards and ensuring the safety of personnel. All components, including the end cable tap box, cable trays, and conduit, must be properly grounded to the building's grounding system. The grounding conductors should be sized according to the applicable electrical codes. When installing the end cable tap box, ensure that it is securely mounted and properly aligned with the busway. The mounting location should be easily accessible for maintenance and inspection. The flexible feeder cable should be routed in a way that minimizes stress and bending. Avoid sharp bends that could damage the cable insulation. The cable should be supported at regular intervals to prevent sagging. When terminating the flexible feeder cable, use the correct crimping tools and dies to ensure secure connection. Follow the manufacturer's instructions for tightening the cable lugs and connectors. After completing the installation, thoroughly inspect all connections and components to ensure that they are properly installed and tightened. Use a torque wrench to verify that the connections are tightened to the specified torque. Test the continuity of the grounding system to ensure that all components are properly grounded. Use a multimeter to measure the voltage and current at the end cable tap box and the bus tap connector to verify that the system is operating within its rated limits. Document the installation, including the materials used, the installation procedures, and the test results. This documentation will be helpful for future maintenance and troubleshooting. Adherence to electrical codes and manufacturer's instructions is paramount. These codes and instructions provide detailed guidance on the safe and proper installation of electrical equipment. Ignoring these guidelines can lead to serious electrical hazards. Qualified electricians have the training and experience necessary to safely and properly install electrical equipment. It is essential to hire qualified electricians for any electrical work. Regular maintenance and inspection are essential for ensuring the long-term reliability of the electrical system. Inspect all connections and components regularly for signs of wear or damage. Tighten any loose connections and replace any damaged components. Consider using thermal imaging to identify hotspots that could indicate loose connections or overloaded components. Always de-energize the electrical system before performing any maintenance or repairs. Follow lockout/tagout procedures to prevent accidental energization. Wear appropriate personal protective equipment, such as gloves and safety glasses, when working on electrical systems. Be aware of the potential hazards associated with working with electricity, such as electric shock and arc flash. Follow safe work practices to minimize the risk of injury. The flexible feeder cable allows for easier connection and disconnection, which can be helpful for maintenance or future modifications. The use of flexible conduit can further enhance the flexibility and protection of the cable. The selection of the appropriate cable size is crucial for ensuring that the cable can carry the required current without overheating. Overheating can damage the cable insulation and lead to electrical failures. The use of cable trays and supports can help to improve the overall aesthetics of the installation. A well-organized installation is easier to maintain and troubleshoot. Proper labeling of all components can help to prevent confusion and errors during maintenance and troubleshooting. The use of color-coded wiring can also help to improve the clarity of the installation. Before beginning any electrical work, it is essential to obtain all necessary permits and approvals from the local authorities. Failure to obtain the necessary permits can result in fines or delays. It is also important to coordinate with the utility company to ensure that the electrical system is properly connected to the grid. The utility company may have specific requirements for the installation of electrical equipment. Regular training on electrical safety is essential for all personnel who work on electrical systems. Training should cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment. The end cable tap box should be sized appropriately for the number and size of the cables being connected. Using an undersized tap box can lead to overheating and electrical failures. The flexible feeder cable should be installed in a way that minimizes the risk of damage from rodents or other pests. Consider using rodent-resistant cable or installing a physical barrier to protect the cable. The use of surge protection devices can help to protect the electrical system from damage caused by voltage surges. Surge protection devices should be installed at the end cable tap box and at other critical points in the system. The installation of a ground fault circuit interrupter, abbreviated GFCI, can help to protect personnel from electric shock. GFCIs should be installed in areas where there is a risk of contact with water. The use of arc flash protection can help to protect personnel from the hazards of arc flash. Arc flash protection can include arc-resistant equipment, personal protective equipment, and safe work practices. Proper documentation of the electrical system is essential for future maintenance and troubleshooting. Documentation should include wiring diagrams, equipment specifications, and test results. Consider using a computerized maintenance management system, abbreviated CMMS, to track maintenance activities and manage equipment records. CMMS can help to improve the efficiency of maintenance operations and reduce the risk of equipment failures. The use of predictive maintenance techniques can help to identify potential problems before they lead to equipment failures. Predictive maintenance techniques include vibration analysis, thermal imaging, and oil analysis. Regular audits of the electrical system can help to identify potential safety hazards and compliance issues. Audits should be conducted by qualified electrical inspectors. The selection of electrical equipment should be based on its reliability, durability, and energy efficiency. Consider using energy-efficient equipment to reduce energy consumption and lower operating costs. The use of renewable energy sources, such as solar power, can help to reduce the carbon footprint of the electrical system. Renewable energy sources can also provide a backup power supply in case of a power outage. The design of the electrical system should consider the future needs of the facility, plan for future expansion, and ensure that the system has the capacity to accommodate future loads. The use of modular electrical equipment can make it easier to expand or modify the system in the future. The selection of electrical contractors should be based on their experience, qualifications, and safety record. Check their references and verify their insurance coverage. Before beginning any electrical work, it is essential to have a clear understanding of the scope of work and the potential hazards involved. Conduct a job hazard analysis to identify potential hazards and develop safe work practices. Communicate effectively with all personnel involved in the electrical work. Ensure that everyone understands their roles and responsibilities. Monitor the work closely to ensure that it is being performed safely and according to the applicable codes and standards. Stop work immediately if any unsafe conditions are observed. Investigate any accidents or incidents to determine the root cause and prevent future occurrences. Continuously improve the electrical safety program by learning from experience and implementing best practices. Stay up to date on the latest electrical codes and standards. Participate in continuing education and training to enhance your knowledge and skills. Share your knowledge and experience with others to promote a culture of electrical safety.